Hello, world. It's something I've been thinking about quite a bit, and it's been coming up in a lot of the conversations I'm having with various enterprise size companies. Quantum and AI are colliding, and the trust architecture for all of our systems is the blast radius. So there's two major shifts that are happening. AI is enabling cyber attacks at an unprecedented scale and speed. And simultaneously, what we're seeing is quantum computing is undermining the foundation for all of our cryptographic infrastructure that we rely upon. Just think about the internet. In order for it to become a software development and e-commerce platform, it required a cryptographic layer enabling encryption of data in transit. Now, the significance of this is as quantum computing becomes increasingly real, which most research estimates put this as somewhere between 5 to 10 years away for like full-scale quantum computing capabilities. But we'll get there even faster for some limited scale quantum computing capabilities. So let's assume in 5 years, we have the ability for quantum computing to be able to have a material impact on decryption of our existing encryption schemes. Now, if you take into consideration what's happening here, you have this acceleration in scale and speed of cyber attacks being facilitated by AI-based systems colliding with new quantum computing capabilities to decrypt data. So one of the things that's really important to understand is the very foundation of our ability to build these trusted systems relies on encryption. And we're seeing a transition to a world where that encryption foundation is susceptible to new attacks. Now, you may think, oh, well, if it's 5+ years away, what's the problem? Well, the problem is today. There's a concept of harvest now and decrypt later. And that means that attackers are able to capture encrypted data today and wait until quantum machines are capable of decrypting it. So it's already happening that bad actors are collecting or harvesting data that's encrypted, knowing that within years they'll be able to decrypt it. So even though full quantum decryption may still be years away, the risk is active now. So research projects estimate that cryptographically relevant quantum computers, maybe they're 5 years away or so. But what big tech is already doing is they're not just talking about this in terms of theory. Earlier this year, Microsoft integrated PQC or post-quantum cryptography algorithms into key components like its SymCrypt library. They're already preparing Windows and Azure and other platforms for quantum safe transitions. Similarly, Apple's has begun this as well, and notably Cloudflare rolled out hybrid post-quantum key agreements by default for a lot of the internet traffic that's flowing through Cloudflare. In fact, by the end of this year, over half of human-initiated traffic via the Cloudflare network will already be protected against harvest now, decrypt later. That's only half. So for most enterprise-sized organizations, this shift to post-quantum is a multi-year process. By most estimates, it's 3 to 5 years it's going to take for large organizations to make this shift to quantum-safe cryptography. So the point being here is it's not optional. It's something that already needs to be in motion for large enterprises. They have to be planning for this. They have to be executing on this now. And what does this mean for business and AI workflows? Well, for enterprises using AI on sensitive data, this means confidentiality has to be baked into the runtime of compute because these agentic systems are intrinsically leaky with data. What everybody should be thinking about is what's the cryptographic lifetime of your data and systems? If we know that post-quantum is on the horizon, that means that the cryptographic lifetime of your data and systems is probably only years. So for large organizations, as I mentioned, the migration to post-quantum crypto can take up to 5 years or more from strategy to full deployment. So everybody should be thinking about this now. Everybody should be investigating and inventorying where their long-lived keys are, what data's encrypted, where AI models that they're training reside, and they need to be building crypto agility. This is about thinking through hybrid classical and post-quantum crypto so that they're ready to shift rapidly when standards and hardware shift. So everybody already in the enterprise needs to be thinking about what is our quantum safe plan. And you need to be evaluating what your PQC options are and what libraries you'll be adopting. So I want to highlight a really innovative research lab. It's the research lab known as the Advanced Technology Research Center out of the UAE. They're the ones who built the Falcon model, language model series. I'll be at the Adopt AI event in Paris later this month. They're hosting Opaque in their booth at the event, and Dr. Najwa Raj will be speaking at the event. They've also developed a PQC library that you should take a look at. They've published an open source component, and they're commercializing PQC under the brand of Quantum Gate. Take a look at what they're doing there. Of the 12 authors of the NIST standard for PQC, 6 are employed at the Advanced Technology Research Center. So they're really leaders in this category. So here's the key takeaway is you need to be educating yourself on this category of post-quantum. You need to be enabling runtime encryption across your AI workflows in order to ensure that your data is protected in motion, at rest, and for every transaction, every handshake. You need to be thinking about how you do verifiable runtimes with encrypted data running in runtime inside of a trusted execution environment. And secondly, start your PQC migration plan today. Catalog your crypto usage, assess quantum vulnerabilities, adopt hybrid key exchange schemes, set up a roadmap with milestones because the window to act is literally closing now. And you need to be thinking about how to protect your data, your models, your trust, not just at rest or in transit, but at runtime. And you need to be thinking through how you build atomic zero trust chains where each link is resilient so that no single event can rupture the entire zero trust chain. Each link needs to stand alone, needs to be atomic. And you have to be thinking about encryption runtime, and you have to be thinking about post-quantum. I'm sharing a couple of links for your further education. And I'm not trying to fearmonger here, but it's just a reality that there are bad actors out there that are already doing harvest now, decrypt later, and everybody needs to be thinking through how to address this. All right, thanks for tuning in.